Welcome back to Tech C, and in this segment, we dive into the innovative world of agriculture where traditional farming meets cutting-edge technology. Our focus, aquaponics, a sustainable farming method that combines aquaculture with hydroponics, cultivating both fish and plants in a symbiotic ecosystem.
Join us as we explore how this emerging technique is reshaping the future of food production, offering a holistic approach that conserves water, maximizes space, and minimizes environmental impact. Gwen? Aquaponics. Aquaponics is the combination of two technologies. We have aquaculture, or the farming of aquatic life, and then we have hydroponics, the planting without soil. In aquaponics, fish waste becomes fertilizers for the plants, and in turn, the plants filters the waste for the fishes. So how does it work? Imagine a fish tank connected to a plant bed. The fish produce waste which is broken down by bacteria into nutrients the plants can absorb. These filtered nutrients helps the plants thrive, and the clean water then flows back to the fish tank, creating a healthy environment for the fish. Setting up an aquatic system can be expensive initially. This system can also require constant monitoring and some technical knowledge to maintain optimal condition. Additionally, while many plants thrive in aquaponics, there are limitations on the variety that can be grown. Traditional fishing methods can deplete fish population and introduce microplastics into the food chain. Aquaponics offers a controlled environment that protects fishes from pollutants. So do you think aquaponics is the future? Well, that I can tell you. The technology is still evolving, but it holds immense promise. As we face challenges like water scarcity and pollution, aquaponics offers a sustainable and efficient way to produce fresh, healthy foods. While it may not replace traditional farming entirely, it could play a significant role in feeding a growing population. Welcome to our next segment on weather satellites, where we look beyond the clouds to forecast the future. These high-tech marvels orbiting our planet provide invaluable data to weather forecasting centers, helping us track storms, monitor climate patterns, and predict weather events with unprecedented accuracy.
And now, as we delve into the skies to uncover how the satellites revolutionize our understanding of Earth's atmosphere, keeping us informed and prepared for whatever Mother Nature has in store. We have Shani on the line. The oldest had a saying, if a bird flies, it's going to be raining. Now, based on the book of the Old Farmer's Almanac, people used to predict the weather by analyzing animal behavior and the state of their arthritic bones. But now, satellites are being used to check the weather that will help farmers gather data to help their farming. This can also be useful for fishing in the ocean where it is determined to be dangerous. But how does it all work? The process of the weather forecasting system solely relies on the machine itself. A satellite uses its sensor to gather different wavelengths such as infrared and visible light. This is mostly used for predicting weather patterns that may turn into storms. Now, the setbacks. Data accuracy might be a problem since weather is unpredictable. Most of the time, the weather is only 80% accurate, and the dilution of the information might be slower to third world countries. But by leveraging advanced technologies such as satellite imagery, meteorological models, and data analytics, we can anticipate the weather patterns, which in turn can help businesses such as flights, logistics, and more importantly, the agricultural field itself. Taxi soars to new heights with a closer look at aerial imagery, where perspective from above paints a vivid picture of our world. From stunning landscapes to urban sprawls, aerial imagery captured by drones and satellites offers a bird's eye view like never before, providing invaluable insights for industries ranging from urban planning to agriculture.
Now, let us take a flight into the realm of aerial imagery, exploring how these captivating visuals empower us to see our planet from a whole new angle, unlocking endless possibilities for innovation and discovery. On the line, Shani.
Aerial imagery works by capturing dozens of photos and then clipping them up into one photo. Which can be used for analysis to figure out which patch has a problem and for monitoring crop health. This works by satellites using advanced baseline imagery in their hardware, which then captures detailed view of the photographs. with satellite imagery having its benefits, drone imagery, on the other hand, is a much more flexible and cost-efficient way to aerial imagery. Why is it exactly? Because it covers a much more ground and because it is much closer. Packed with cameras that will take photos in high definition, it helps the agriculture field find problems a lot more faster than satellite imagery. Although it is mostly used to check which patch of the field has problems, drone imagery, on the other hand, can be used to check sea levels with a much more durable drone. Although this is a great way to scan the area, it is deemed way too expensive by a lot of companies. In the case that they do use it, a company that owns satellite or drones may provide them pictures of their agriculture field. Tired of limb plants? Introducing vertical farming, the number one solution for mass-producing crops with minimum space allotted. Picture this: skyscrapers transformed into lush green gardens, bursting with the freshest veggies you've ever laid your eyes on. Say goodbye to bland, wilted produce and hello to vibrant, flavorful delights, grown right in your own neighborhood. With vertical farming, every day is a farmer's market extravaganza, bringing the farm to your doorstep, one juicy tomato at a time. Join the vertical revolution. Let's grow up, up, and away.
To explore precision agriculture where technology meets the soil to revolutionize farming. In this digital age, farmers harness the power of data analytics, GPS technology, and drones to optimize every aspect of this operation, from planting to harvesting. Join us as we delve into the world of precision agriculture,
Where smart sensors and machine learning algorithms enable farmers to make data-driven decisions, maximizing yields while minimizing environmental impact. Together, let's uncover how this innovative approach is reshaping the future of farming, ensuring food security for generations to come. Tani? Precision agriculture talks about the integration of IoT in day-to-day machinery. These are mostly used in farming because precision agriculture tackles about the precise way of harvesting. This can include, but not limited to, automated farming, GPS to visualize the area of the field, or LiDARs. Like this tractor, for instance, most tractors are driven by a farmer. But with precision agriculture, an automated tractor can replace a human-driven one. A 24/7 tractor that doesn't run on human labor is much more suitable for profit amongst companies. But in these cases, innovation disrupts human labor and employment. To prevent these from happening, there are laws in place to protect humans from the innovation of these processes. Embracing precision agriculture not only optimizes and yields resource usage, but also cultivates a sustainable future for farming. Although it may be scary, but a future of farming solely relies on precision agriculture. Today, we shall shed light on LiDAR technology, a groundbreaking tool reshaping our understanding of the world around us. By emitting laser pulses and measuring their reflection, LiDAR creates highly detailed 3D maps used in urban planning, forestry, and more.
let's look into a fascinating realm of LiDAR, where precision meets perception, unlocking new dimensions of knowledge and innovation. Gwen, LiDAR, or light detection ranging, works by firing laser pulses that bounce off objects and return to the sensor. By measuring the time it takes for the light to travel, LiDAR can create incredible detailed three-dimensional models of its surroundings. Unlike traditional methods, LiDAR is a non-invasive way to gather data about crops. It doesn't harm the plants and works equally well in all lighting conditions. This allows farmers to First, create precise field maps. Imagine a detailed 3D map of your entire field, highlighting variations in elevation and terrain. LiDAR makes this possible. Second, optimize fertilizer use. By creating detailed models of plant health and growth patterns, LiDAR helps farmers pinpoint areas that need more or less fertilizers, leading to more efficient resources use and healthier crops. And lastly, improve crop yields. With a deeper understanding of their fields, farmers can make informed decisions about planting and resource allocation, ultimately maximizing their harvest. While powerful, LiDAR technology isn't without its challenges. The main challenge is cost. Setting up a LiDAR system can be expensive, potentially limiting its use for smaller farms. Second, power. LiDAR systems require a significant amount of power, making them less practical in remote areas with limited energy sources. Third, size and weight. Some LiDAR systems are bulky and heavy, making them unsuitable for use with drones or other mobile platforms. And the last challenge is regulations and privacy. In some areas, LiDAR use might be restricted by regulations or privacy concerns, especially when deployed in populated areas. While challenges exist, LiDAR's potential is undeniable. As the technology becomes more affordable and accessible, it could become a viable tool for farmers everywhere, from creating 3D models of fields to optimizing resources allocation. LiDAR offers now a level of precision and efficiency for agriculture. It's a technology that's changing the game, not just in farming, but across many industries.